And basically, convolution is the process or the arithmetic process that happens inside the system when you apply a certain input. So if we are talking about discrete time systems, remember we have a system here with a certain impulse response, h of n, and I apply an input x of n, and I'm getting a certain output y of n. So the mathematical relationship between all these three variables goes as follows: x of n, and we'll use the asterisk sign or the star, h of n equals y of n. So this one reads like the input x convolved. So convolved with the impulse response h will produce the output y. Similarly, we can say the same thing, h of n convolved with x of n will produce y of n. Now this process, the convolution, it's not something, let's say, as simple as addition or multiplication. It's basically a combination of both. Like it's a multiply and add, and that's why they call it the convolution sum, because there will be some addition, but there will also be multiplication. There are three ways to do the convolution in discrete time. So one of them is the standard way. Standard. We do not prefer it. It's going to be a long process. There will be a lot of rooms for error in your case. Then we have the tabular format, table method, and we have the matrix method. So both of them are easy to achieve, but we'll talk about convolution in all three cases. And we'll talk about how to find it and standard, and you'll see how long to finish this process. And you'll see that with the tabular and matrix forms, it's very easy and very straightforward. All right, so why do we prefer LTI systems? We've taken that in previous weeks, the linear time invariant systems. So basically, they are systems that are realizable. They can be available in real life. There are a lot of mathematical tools to solve them. They have their important role in engineering. They are easier to analyze, and some cases when the system is not LTI, they will approximate it to LTI models, just for simplicity. All right, so what is convolution in discrete time domain? As I mentioned, y of n is x convolved with h. Now, this process here is the summation. That's why they call it the convolution add or the convolution sum from negative infinity to infinity, x of k, h of n minus k. Notice one important thing, the domain for x and h has changed into k. So even like your function is given h of n, y of n, the first thing we'll do is to transform these domains into another domain, k, which is like it's the same variable but a different representation to avoid confusion with the original index n. So h of n is an LTI system response to impulse input. So the convolution x of h, x convolves h evaluated at any point n, is basically a weighted sum of elements of x where the weighting is given by h. So at any point of n, let's say, for example, y of 0 is going to equal summation from k equal negative infinity to infinity, x of k, h of k, h of negative k, because at n equals 0. And this one, basically, you are multiplying x and h for all values of k. And that's why we call it it's a weighted sum. Weighted sum of what? So x of k, that's the original summation, weighted by the values of h of minus k, or the time reversed and shifted version of n. So from now on, the asterisk sign will be the symbol of convolution. Time domain, discrete domain is the same thing. Convolution still have the same symbol. So it will be always used to denote convolution, and it's not multiplication. Multiplication from now on will use the dot sign. So there is a lot of theory on the convolution, and we'll see that in this lecture. All right, so how to process this one? Now we'll talk about the standard way, how to compute the convolution. We have this summation. So first, plot x of k and h of minus n minus k as a function of k. So we have the functions x of n and h of n given. First, you have x of k, so transfer the domain, and h of k. Then you'll do time reversal, h of minus k, and then you'll do the shift h of n minus k. All right, now the values of k will be given to you. Like when you see the function, we'll do the example now, it will be more straightforward. So the first thing you do is you have those. Now, initially consider an arbitrarily large negative value of n. It means that you have a large value of n. Now, by the way, it's going to be shift to the left or to the right for n. It's going to be shift left to the right or right to the left, because I have minus k, but I'm adding a positive value. So it's going to be all the way to the left. So basically, let's assume h of k is something like this, just two pulses at 0 and 1. That's h of k. Now, h of negative k is going to be what? The same thing, but it's going to be negative 1 and 0. I'm just reversing, just time reversal. Or if you want for clarity, it's going to be something like this. It's time reversal. Now, h of n minus k will be the same thing, but I have my indices n minus 1 and n. That's h of n minus k. So instead of each point here, I'm shifting to the right by the value of n. So this will result in n minus k being shifted very far to the left on time axis. Then to do this mathematical operation, you start sliding this one with respect to x until there is an overlap. Or you can just look at this function. I have x of k, I have h of n minus k, then I do the summation for all possible values of n. So for example, y of n is going to equal summation or y of 0, summation k equal negative infinity to infinity, x of k, h of negative k. In fact, let me do an example for this to have a clear understanding. Okay, so I'll open the whiteboard. So let's assume that I am not seeing anything. Okay. Duplicate. Better. Okay, so let's assume I have x of n equal 1, 2, and 1, 3, and 2. Have we taken this representation for discrete signals? We've done this representation for discrete signals. So basically this one is as 0, 1, and 2. That's the time axis. So the indices, this is 0, 1, 2. So at 0, I have a pulse of value 1. At 1, I have a pulse of value 3. And at 2, I have a pulse of value 2. So that's 1, 3, 2. So this is my x of n. And h of n equals 4 and 2, which is basically 2 pulses, 0, 1. This is 4, and this is 2. And let's apply the convolution expression here. Convolution y of n equal summation from negative infinity to infinity for which variable k equal x of k h of n minus k. All right, so first thing to do is to find h of negative k. So now this one is no longer my index, and it's becoming k. So the time reversal part or version of this, so at 0 it's 4, so at 0 is going to remain 4 time reversal. Now at 1 it was 2, so at -1 it's going to become 2. So -1, that is 2. So this is x of, sorry, that's h of negative k. Okay. All right. So then to have h of n minus k, I will have the same exact thing, but for each index, I will add n. So it's going to be this one, n minus 1. I have the value 4. At n, the value is 2. And this one, x of k, remains the same. So let's find y of 0. Equals what? Summation from k equal negative infinity to infinity, x of k, h of minus k, right? Now let's take all possible values for k. The summation is from minus infinity to infinity. Now if you look at these graphs here, so in this case at n equals 0, so this is at -1 and this is at 0. Okay, so it's going to equal. Let's start for values of k equal -2. It's going to be x of -2, h of what? -2, 2, plus x of -1, h of 1, plus x of 0, h of 0, plus x of 1, h of -1, plus x of 2, x of 2, h of -2, right? Now, do I need to proceed for x of 3 and y of 3, x of 3, x of 4? If you think about it, look at the x variable. I have values from 0, 1, 2. Like this one, what will be x of -2? X of -2. So that's -1, that's -2. What is the value there? 0. So this term is 0. What about this one, x of -1? It's also 0, it's gone. Now, what about x of 0, h of 0? X of 0 is how much? 1. What about h of 0? Here. This is my h of 0. So what is the value? 2. So I have 1 times 2. So that's the first expression. Plus x of 1 is how much? 3 times h of -1. 4. Plus x of 2 is how much? It's 2 times, what about h of -2? 0. So I only have 1 times 2. It's going to be 2 plus 3 times 4. That is 12. And the answer will be 40. So that's y of 0. Now, you mean those or those? This one here? Just look at your function. X of -2, I have my, this is my original variable x. And h of 2, that's my h. I mean those, -2, 2, no, just arbitrary. We are just trying right now. So I've just put these arbitrary values. But there's a procedure where to start and where to finish. We'll come to that later. All right, now you want to find y of 1. Same process. Try, and then you have this convolution sum. Now, in this case, it's going to be summation of what? K equal -infinity to infinity, x of k, h of 1 minus k. Then substitute for different values of k. So we know that the values for x has, like, will have only values at 0, 1, 2, right? So I can start with a 0, 1, 2. See the point here? So instead of doing the -1 and 3 and 4, there are no values for x at -1 or 3 and 4. So it's going to be equal x of 0, h of 1 minus 0, 1, plus x of 1, h of 1 minus 1, 0, plus x of 2 times h of 1 minus 2 minus 1. And same thing. X of 0 is how much? It's on top. I think it was 1. X of 0, it's 1 times h of 1 is 0, plus x of 1, it was 3, I believe, times what about the value of h of 0? It was 2 or 4. 2. 4. So this is 4. H of 0 is 4. Okay. Plus, what about x of 2? It was 2 times h of -1. Here, h of -1, that's 2. And it's going to equal 12 plus 4, that is 60. And so on. You keep doing that until you finish all possible values of n where the function will have a value, y of n. Now notice this process is quite long. Like there should, of course, we'll do now an easier way to find this convolution. But let's go back to the slides. Yeah. The original one. Yeah, we'll look at the original. This one here is when we do this graphical representation for convolution. Like slide it all the way there, then start sliding, and we have x. And then you see overlaps. It's quite confusing. Well, I prefer like to go with this one. But this one here, write a mathematical expression for x of h, or actually you have a point. I think h of a, will use this one actually. Yeah, thank you. We're not looking at this one. We'll look at this one because I have h of n minus k. I'm looking at this one. So instead of at h of 0, I will have 2. H of -1, it's 4. Yeah. So we're doing correct, I believe. 3, 4. Okay, x of 1 is how much? 3. H of 0. Okay, this one is 2. Thank you. And h of 0, that's 2. And h of -1, this is 1 is 4. So it's going to be 6 plus 8, and that's 14. Yeah, thank you. Oops. We are looking at this one. This one is no longer our interest or our function to look at. Anyways, let's go back to the slides from current slide. Duplicate. So it's saying that, okay, write the mathematical expression, which is this one. Increase n gradually until the expression for x of times h of n changes form. Record the interval over which valid. Repeat steps 3 and 4. An arbitrary large positive value that corresponds to h minus k being shifted far to the right, and so on. To be honest, in the exam, I will not ask you this, because to me, I want you to get the answer for the convolution. For the exam, I will ask you to do the tabular method. And that's what we're going to do right now. All right, so there is an example on this, how to do this convolution. So this is x of n, for example. X of n equals 1, 1, 1. So I have at 0, it's 1, at 1, it's 1, at 2, it's 1. So that's the index was 0, 1, 2. And h of n, so h of n equals 1 and 2. Assuming the value here is 2. That's my assumption. And this is 1. And this is index 0, and this is index 1. So start by doing the flipping for h of k. So h of minus k is this one. And then shift all the way to the right. To the left, sorry. To the left. So this one is n minus 1, and this is n. And these are the values 2 and 1. And then you just apply the convolution sum until you have these overlaps. Or you go to the original formula and substitute values for x and h. That's the original method. That's the graphical way, or the arithmetic method. So for example, I think this is this example here. So you have these values for h and you have these values for x. Again, represent the convolution. The solution is there. And there you go. That is the answer. So basically, y of n equal x of n convolved with h of n. You have the convolution sum. Now at y of 0, you have x of k, h of 0 minus k. Then you apply the summation for different values of k. So let me see if the answer is there. So that's at n equal 3, at n less than 0. And okay, so this slide is not very clear. So y of 0 is this one. It's 0 plus 0, 1 times half, plus 0 times 2, plus 0 times 0. So basically you have the summation. K, you have x of k, and k, you have the summation. So let's try x of 0, h of 0, plus x of 1, h of negative 1, plus x of 2, h of negative 2. Do I have value for 2? Okay. Okay, I think that's it, because we have only 2 values for x, the 0 and 1, right? So there's no need for this term. What about x of 0? How much? 0.5 times h of 0, how much? It's 1, plus x of 1 is how much? 2, plus h of negative 1 is 0. So you have 0.5. There you go. That's the first answer. That's for y of 0. Now y of 1. Y of 1 equals summation k equal negative infinity to infinity, x of k, h of 1 minus k. Again, similarly, we have only values for k at 0 and 1. For x, so I have x of 0, h of 1, plus x of 1, h of 1 minus 1, that is 0. So let's say how much is x of 0? 0.5 times h of 1, it's 1, plus x of 1 is how much? 2 times h of 1, that is h of 0, that is 1. So 0.5 plus 2 is going to be 2.5. So that's for 1. Let me see. There you go. 2.5. Y of 2 equal summation k equal negative infinity to infinity, x of k, h of 2 minus k is going to be equal x of 0, h of 2 minus 0, which is 2, plus x of 1, h of 2 minus 1, that's going to be 1. How much is x of 0? It was 0.5 times 1 plus x of 1, 2 times h of 1, it's 1. So 0.5 plus 2 is going to, again, 2.5. That's y of 2. There you go. That's y of 2. Now, last point is for y of 3. Equal summation k equal negative infinity to infinity, x of k, h of 3 minus k. So I will have x of 0 plus h of 3. 3 minus k. We did the 2, right? Now it's 3 minus k plus x of 1, h of 2 minus 1, that's 2, right? Or 2, yeah, 3 minus 1, that is 2. So x of 0 is 0.5 times 1. H of 3, H of 3 is 0. Yeah, that's H of 3. That's 0 here. Plus x of 1, 2 times 1, that's going to be 2. That's y of 3. And you can go on and you realize that the convolution will stop at 3. So you have only values from 0 to 3. This is the standard method. Now we'll see the other methods, the tabular method and the matrix method. Yeah. It's the same thing. That's the standard way. Okay, before going to the other methods, so some properties here is commutative, means that if x convolves h is going to equal h convolves x. So like they are interchangeable. It is associative. Again, convolution is nothing but multiplication and addition. So you can, let's say, like remove the parentheses and you put them here, assuming that you have 3 variables, or assuming you have 2 systems here. So that's h1, and that's another one here, h2. And assume your input is x and the output is y. So you can finish x convolves and h1 initially, then you convolve the result with h2, or you have the equivalent system, h1 convolve with h2, then you convolve the result with x. Distributive, it's like multiplication. When you have 2 systems like this and you have the convolution, you can distribute it at each one of them. All right, so this is just some properties for convolution. Okay, so let's check this example, and let's go back to one of the other examples here. For example, this one. And on the whiteboard, I want to represent these convolutions or these functions, sequences, and I ask you to do the convolution. So let's do the tabular method first. Okay, so we have x of n equal 0.5 and 2, and h of n 1, 1, and 1. One important thing here, this is a sequence, so it's a function with respect to n. Now, what will be the values of n? If it's nothing indicated, the first index here is 0, the second index is 1, and so on. So this is index 0, 1, 2. What do you mean by that? So when I want to plot this function, this is considered like the time domain and like any function, but this is a sequence. We deal with integer indices. So this is index number 0. I have a pulse of value 1. I'm drawing h of n. At value 1, at the second sample, another pulse. At 2, that's a third pulse. Similarly here for x of n, I have the first one half and the other one a larger pulse. Now, let's say if I want to have the sequence starts from a different point than 0. So how to deal with that? You can just simply put an arrow. Now, if you see an arrow like this means that my index number 0 is here, is at the center. So in this case, this is index number 0, this is index number 1, this is going to be index number -1. So if I want to plot this one, when I find the arrow like this, I will have, it's the same exact plot like here, but I will have a sample at -1, a sample at 0, a sample at 1. So they are exactly the same, but my indices are different. Because sequences we deal with, like we have the index and the value. All right, so if it's not stated, if it's not written, by default, my first value will be at index number 0. Okay, the result for this one, when we did the standard convolution, so y of n equal, so the first one was half, 2.5, 2.5, 2. So 0.5, 2.5, 2.5, So this was the output when we got it with the standard method, and we saw how long it was. Now let's try the tabular method. Tabular method, basically, I have x of n and I have h of n. I just write them as they are. So I have 0.5 and 2, 1, 1, and 1. And here on top, it's optional, but I'll put the index. That's 0, 1, 2. So I'm going to do the tabular method. Tabular method. And you just do multiplication. Like you remember how we did multiplication back in the day. So let's multiply all elements of that 0.5, all elements of x with the first element of h. So 0.5 times 1 plus 2 times 1, how much? We do not add them, actually. We multiply 0.5, 2 times 1, it's 2. You do not add. So that is the first thing you do. Now, second. Now, notice here, at h, I'm going to jump 1 step. Same thing here, jump 1 step. Now, you do multiplication again. 0.5 times 1, that's 0.5. 2 times 1, 2. Now, we'll do another skip. So that's 1, 2. 1, 2. 0.5 times 1, 0.5. Sorry, I'm multiplying by this one now. 0.5 times 1, 2 times 1, 2. And then you just add. 0.5, there is nothing here, so I'll assume it's zeros. So I get 0.5. 2 plus half, 2.5, 2.5, and 2. So if I want to write this answer, y of n equals 0.5, 2.5, 2.5, 2. Now notice, aren't they the same? 0.5, 2.5, 2.5, and 2, same. So this is the tabular method. It produced exactly the same answer as what I got from the standard wave convolution. Now think about the amount of effort I spent here is like close to minimal. Get the idea? Let's try another example here. Let me see this one. Okay, so x of n equals 1 for all values from 0 to 4. And h of n from -2 to 2. Okay. So, you know what? I'm going to copy this lot. No need to copy it. So it's going to be all ones from 0 to 4, and the other one -2 to 2. So x of n equal 1 and 4 and 0 elsewhere. H of n also 1, but from -2 and 0 elsewhere. And I ask you to do the convolution. Now, if you think about it, if you want to do the standard way, here, how many samples do I have? 5. 0, 1, 2, 3, 4. So I have 5 samples. The other one here, also 5. -2, -1, 0, 1, and 2. That's 5. So I will have like large number of multiplications and addition to do. So the standard way is time consuming in this one. Now, how are we going to do it in the tabular way? Similar to the previous one, but notice one important thing. This one, it starts at -2. So if I want to represent it in the, let's say, sequence form, it's going to be 1, 1, 1, 1, 1, and my arrow will be here. X of n, 1, 1, 1, 1, 1. And the arrow will be there. Again, if there's no arrow, the default starts at 0. Okay. Before we start, how do we determine the initial point of convolution and the last point of convolution? And how many samples do I get? Or how many samples? Like this one, I have 5 samples. Oops. Okay, okay, this one here, I have 5 samples. The other one is 5 samples. So we do it like this. Ny means the number of samples Ny equals the number of samples in X plus the number of samples of H minus 1. That's one of the first rules you need to memorize. The number of samples at the output equals the number of samples at the input plus the number of samples at the filter minus 1. So it's going to be equal 5 plus 5 minus 1. I will get 9 samples. So I know my output should have 9 samples. That's the first point. Second point, where do we start? N basically is going to be between N initial or NX initial plus NH initial and NX final plus NH final. Basically, it means that my output will be between the 2 initial points at X and H and the final points of X and H. So in here, what's the initial value I have? I start at 0 and I'll finish at what? 0, 1, 2, 3, 4. So I'll finish at 4. Here, I start at -2, I'd finish at 2. So if I want to substitute the values, what's the first value of X? It starts at 0 plus -2. What is the final value of X? At 4 plus final value of Y at 2. So my convolution output should be from -2 and to 6. Okay. So simply now I can have my output. I know my output will have values from -2, -1, 0, 1, 2, 3, 4, and all the way to 6. 5, 6. So these are where my output will be. Now let's apply the matrix method. Matrix method, in this case, is going to be a little bit long, but quite easy. So 1, 1, 1, 1, 1. So that's my X and my H. Similarly, 1, 1, 1, 1, 1. They happen to be the same for this example. Okay, so let's do the multiplication. Multiply all this by this one. It's going to be exact replica. Now shift 1. Now I'll be multiplying by this one. Similarly, now shift 2 points when you want to multiply by this one. Shift 2 spaces. Yeah, I'll like on this one, I will shift 4 times. So to avoid confusion, you can put a 0 exactly, 0 directly here. Then you have 1, 1, 1, 1, and 1. Then you want to multiply by this. So I have 3 zeros. 1, 1, 1. By the way, it's better to have them organized because you're going to do summation at the end. And you don't want to confuse one of the elements with one column with another column. The last one with this one here, 0, 0, 0, 0, 1, 1, 1, 1, 1. And then that's it. You do the summation. So first element, 1. Second element is going to be 2, 3, 1 plus 1 plus 1 plus 0, 1 plus 1 plus 1 plus 1 plus 0. That's going to be 4. You have 5 ones. Then 4, 3, 2, 1. Let's count them. We said like the count should be 9 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 samples. Now just fill these values into the chart I put here. Or you can say simply that I'm starting at -2 and I'm finishing at 6. So this is -2, this is -1, this is my 0. So I put my arrow here, and this is the output. There's the one here. So there you go. That's my 0 sample. That's the one at 0. This is -1, -2, 1, 2, 3, 4, 5, 6 samples. Is it clear? So in this slide, they did it, I think, in the standard way. Yeah, there you go. At each end, just find the value, and we got exactly the same response. So you see here at -2, it's 1. At -1, it's 2. At 0, it is 3. Let's go back and confirm there. At 0, it is 3. At 1, 4. At 2 is 5, and so on. So this is the tabular method to find convolution. Is it clear? This right now is the tabular method. The one in the slide is the standard method. The one I just did now was the tabular method. And there you go. This is the table method here. It is shown here, though I would have preferred this one is to be exactly aligned to this one, and we'll do the shifting later. Okay. Now the other method is the matrix method. Matrix method, again, it's an easy method. In the exam, you have the freedom to choose whatever you want. Matrix method is also a simple method. So we agree the number of samples, the initial point and the final point, you have to do them regardless of what method you are trying. Now the matrix method, you have it like this. So you write X and H. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so you just draw a matrix. Okay. Okay, so this matrix, and you just multiply all elements. 1 times 1, it's 1. 1 times 1, it's another 1, and so on. You just multiply by the numbers. It's going to be all ones because all my elements are ones. So it's not that hard. Now, how to fill the elements in the output? Okay, so these are my results of the multiplication. Now, I did this because I want to take the diagonals of this output. So this is the first diagonal. This is 1. This is the second diagonal. 1 plus 1, that's 2. Third diagonal. 1 plus 1 plus 1, that is 3. Third diagonal. 1 plus 1 plus 1. I think, there's this one I forgot to add. Okay, so 1 plus 1 plus 1, you have how many ones? 4. This diagonal here, 1 plus 1 plus 1. Okay, so that is 5. Then 1 plus 1, they have, now you notice now we are going backwards. 3, 2, and 1. Count the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and you start at -2. Clear? So again, it's just a matter of preference. You want to do the matrix method, you want to do the tabular method. I do not recommend using the standard method. It's time consuming and you have large number of samples, like in this one here. Like in the slides, they have done it 9 times because I have 9 output samples. Now you notice at n equal -2, -1, 0, 1, 2, 3, and there is 4 and 5 somewhere there. And here is the output. And I got the same thing, like literally in no space with the minimal amount of math. Similar thing in the matrix form. Is it clear how to do that? Convolution. Okay, so here's another example. Now it says that how to convolve x of n 24642 with h of n. So let's do that. 2, 4, 6, 4, 2. X of n. 2, 4, 6, 4, 2. And y of n, sorry, h of n. 3, negative 1, 2, 1. 3, negative 1, 2, and 1. So let's do it with the tabular form or tabular method. So 2, 4, 6, 4, 2, and 3, negative 1, 2, and 1. So that is x, and this is h. Okay, so let's do multiplications. So 2 times 3, that is 6. 4 times 3, that's 12. 6 times 3, that's 18. 4 times 3, that's 12. 2 times 3, that is 6. Now we'll shift another space, multiply negative 1, negative 2, negative 4, negative 6, negative 4, negative 2. Shift by 2 spaces, multiply by 2. 2 times 2, that is 4. 4 times 2, that's 8. 6 times 2, that's 12. 8 and 4. And then shift by 3 spaces, we'll multiply by 1. So I'll get 2, 4, 6, 4, 2. Then you just do the summations. So my first element is 6. 12 minus 2, that is 10. 18 minus 4 and 4 will cancel each other. So I'll have 18. 12 minus 6, that is 6. Plus 8, that is 14. Plus 2, that is 16. 6 minus 4, that is 2. Plus 2, 12, that's 14. Plus 4, that is 18. 8 minus 2, that is 6. Plus 6, that is 12. 8, 2. And that's it. So it's going to be 6, 10, 18, 16. 6, 10, 18, 16, 18, 12, 8, 2. And that's it. Quite straightforward. Is it clear how to do the matrix method? Okay, so how to perform convolution in MATLAB? Basically, it's the simple command conv, and you have to put the parameters, the coefficients of x and coefficients of h. X and h. And regardless of what is the order, because we said convolving x and h equals convolving h and x. Now, what about the values? How to determine the values of the start and the end? We said the rule, the starting value is the initial point of x plus the initial point of h. And the final index will be at the final point of x and the final point of h. So let me do an example here in MATLAB. Okay, we'll wait MATLAB to open. Okay. So let's open a new function. So let's say initially x equal, I have the values 2, 4, 6, 4, 2. And h was having the values 3, negative 1, 2, 1, 3, negative 1, 2, and 1. And y basically is going to be convolving x with h, and we'll see the output in this case. And there we go, that's y, 6, 10, 18, 16, 18, 2, 8, and 2. To plot discrete functions in MATLAB, we use the command stem. Now, if my indices are from 0 onwards, I don't have to put the values of n, so I just say stem y, and it will automatically plot the function with respect to n starting from 0. So here starts, it starts the sample at 1, 2, and 4. So to fix that, I will make the values of n equal 0. So the output, how much is the length for the output? In this case, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be to 7. And then it's going to be n comma y. And there we go. So my first sample is at 0 and the value is 6. The last sample is at 7 and the value is 2, as explained here. All right. So if I have the function, let's say 6 starts at -2, so I would say -2 to 5, because that's where my convolution will start. And the output here is shown, starts at -2 all the way to 5. So it's pretty straightforward. I'm not sure, have you done that in the class? The stem function, the stem command. Have you done the lab? Command stem and discrete signals. Stem. No stem, just plot. Okay. So basically to draw discrete signals, we use the stem. Because if I use the command plot here, it will fill the gaps with the straight lines. Like the signal will no longer look discrete. Like if you look at the output here, that's not a discrete, that's a continuous time function or a continuous function. So just to plot the discrete time values, we use the command stem. That's the main difference between stem and plot. There you go, something like this. Okay. Let's continue. Slideshow from current slide. Okay, so this is how to plot the function. As I mentioned, this is the rule to find where, let's say, the starting point of the convolution. So that's an x initial or x naught and h naught. They have x1 and h1. Those are the final points for the filter and the input, or the impulse response and the input. So this is the problem that we just solved with all ones, and you have the first sequence x of n, all ones from 0 to 4, and h of n from -2 to 2. Okay, here's another example. Using the tabular method, you have 2, 1, -1, 0, and -3. And h of n, you have it 1, 2, and -1, but the center is at n equals 0 at 2. And I'm not sure if, like, do you want me to solve it, this question, the convolution, or it's fine? It's pretty straightforward. You use the tabular method or the matrix method, and you will get the answers. For example, here it has in the slides, it's being done using the matrix method. As I mentioned, you don't have to worry about the indices for now. Once you identify them at the beginning and the length of the output, then you can just fill the output and you put the proper indices there. Okay. Another example here. That's something I think we've done it with the standard way. Here is solved with the matrix method, pretty straightforward. Okay, so yeah, that was the exact same result we got before. Okay, now that's a good question. Given an input signal x of n equals 2 delta of n plus 2 minus 3 delta of n plus 2 plus delta of n minus 1, and the impulse response delta of n, I'm gonna copy the question because this is the kind of question you may face in the exam. Copy. Okay. Now, if you are given this example in the exam, how are you going to solve it? Now, remember, like I used to give you x of n as something like this, and h of n, again, something like this. But here I have it as a function of deltas. So how to go from this delta's representation into something similar to this? Now, if you want to plot 2 delta of n plus 2, how are you going to do that? You know how to plot the delta, right? Delta of n. It just pulse at n equals 0 when the value is 1. Now, what about delta of n plus 2? Shift left or right? Left. If you have it a positive value, shift to the left. So here I have it like this as a -2, and the value is 1. Okay, and then you multiply do 2 delta of n plus 2, then it's going to be the same exact pulse, -2, and the value is 2. All right, so I'm starting at -2, and the value is 2. So x of n, I'm going to clean it a little bit. So x of n, I have 2, but this is at index -2. What about index -1? Is there any value there? Here, -3 delta of n. So this is delta of n times -3. So I'll have it like this, -3. Is there something n plus 1? No, so there's no value at -1. So here it will be a 0. Because this one here is shift to the left. Here is exactly at the center. So I have -3, and I'll put the arrow there. Why? Because this is where I have no shifts. That's at 0. And this one shifted to the right by 1. So that's it. That's my x of n. Well, h of n, so here shifted to the left by 1. So I have 1. And I have 1 shifted to the right. Is there 1 at the center? At delta of n. Is there any point at delta of n? No. And h of n, there's nothing, just delta of n. So I have 0 here, and that's my reference point, or that's my 0 index. And I have -2. So in the exam, trust me, you'll be given something like this. The first thing is to come up with these, because otherwise you will get a very incorrect answer. And that happened actually last semester. A lot of students didn't know how to deal. They thought, okay, I have 1, I have 2, so they wrote this one as like this. I have 1, -2. They didn't realize that these are shifts. So this one is shifted to the left, so that's at index -1, and this one is at index equal 1. At index equal 0, there is nothing. Clear? Well, it is in the recording, so inshallah, students will not miss this point. All right, so I have my sequences, x of n and h of n. Now, what will be the initial point? So my output will be between which points? What is the first index here? -2. What is the first index here? -1. So it starts at -3, which is -2 plus -1. And it ends at, I have 1, I have 1, it ends at 2. How many samples? Nx plus Nh minus 1. So that's Ny. How many samples of X? 1, 2, 3, 4. That's 4 samples. Plus how many samples of H? 3 minus 1. So I will get 7 minus 1, 6 samples at the output. Clear? All right, so let's do the convolution. Let's do it with the tabular format. Again, it's optional. Tabular matrix is up to you. So I'll do it this way. I'm going to do the matrix one. 2, 0, -3, and 1. And I have 1, 0, -2. 2 times 1, that is 2. 0 times 1, that is 0. -3 times 1, that's -3. And 1. Everything times 0 is going to be all zeros here. And the last one, 2 by -2, that's -4. I have 0. No, -3 by -2, that's 6. 1 by -2, that's -2. Okay, let me draw these lines to know that these are my inputs, so they will not be included into my results. So what will be the first sample? So I have it like this. 2. I have 0. Okay. Always put these, what they call it, oval shapes to know that you have counted the points. So I have -3, 0, and so you'll have -7. 1, 0, 0, that's a 1. 0 and 6, that is 6. And we have a -2 here. Let's confirm how many points. 1, 2, 3, 4, 5, 6, which is the length of the output. And where do we start? So this is -3, -2, -1. I will put the arrow here indicating that's my 0 index. So that starts at -3. I started at -3. Okay, so best way to confirm it in MATLAB, since I have it already opened. So the coefficients of X were 2, 0, -3, and 1. 2, 0, -3, and 1. And the values of H, 1, 0, -2, 1, 0, -2. And we said I will have the values -3 to 2. And that's it. I'm ready to do the display, evaluate. So my outputs, 2, 0, -7, 1, 6, -2. 2, 0, -6 as -7, 1, 6, -2, exactly the same. And the plot of the output. So at 0, I have the value here, 1. And at 1, I have it 6, -2, and so on. All right. Okay, now we'll go with one of the most important terms in the course, something we call it impulse response. Impulse response basically is the output of the system when you apply impulse. Basically, let's assume the scenario that I have a system with some unknown response. And you were given the task to know what is the response of this system. So you have x of n, and you get y of n. And let's keep it as a question mark. And we know that y of n equals x of n convolves with this question mark thing that I don't know what is the behavior for this system. So to determine this behavior, apply delta of n. or let x of n equal delta of n. Delta of n is the impulse signal. So that's the Dirac delta Dirac delta, or the impulse signal. So in this case, what will happen? One of the properties of the impulse response, x of n convolved with delta of n, will result what? Anything you convolve with delta is going to remain the same, x of n. Anything you convolve with delta, let's call it f. It's going to be f. Now what will happen is, now instead of x of n, I'll apply delta of n in this case. So the output here, y of n equals delta of n equals convolved with this unknown response that I have. Now, however, I will get an output because I have the system with unknown behavior and I applied a certain input, I'm getting the output. In this case, the output will become h of n, or h of n equal x of n convolved by h of n, but at condition x of n equal delta of n. Basically, if I have a system with unknown response, I just apply an impulse for x, and whatever the output will be, it is the system response. H of n equal x of n convolved by h of n, or simply I can say h of n equal y of n at x of n equal delta of n. So the impulse response is the output. If I want to put it in a definition, the impulse response is the output of the system when the input is the unit impulse. That's it. That is the impulse response. And that's why we always symbolize it with h of n. That's what we call the impulse response. Because we knew the behavior when we applied delta of n instead of x of n to get the output. All right. So the response, slideshow from current slide, duplicate. The response h of a system h to the input delta of a system, a certain system h, so the input delta is called the impulse response of the system. So in this case, h equals the transformation of delta. For any LTI, so this one is transformation. Formation. For an LTI system with input x, output y, and the impulse response h, this is the relationship between all these variables. In other words, an LTI system simply computes a convolution, which is basically what we have been doing so far. It's just when you have a system at the beginning, I have x, I have y, and there's h. The relationship between all those is given by this expression. Furthermore, an LTI system is completely characterized by the impulse response. Characterized, like we can check stability, we can check if it's the system is linear, time invariant, bounded input, bounded output, and many other causal, and so on. So that is, if the impulse response of LTI system is known, we can determine the response of the system at any input we may have. Another response here called the step response, not widely used, I think mostly in the control systems, the course after this one. The step response is the output of the system when you apply a unit step function. So here, that's the unit step function. You apply it to this one, the transformation, that's the system, and you have a certain output there. So response S of a system H is input U, called the step response. The impulse response H and step response S are related. Yeah, this one, there is no need to worry about it. Basically, the impulse response is the step response minus a shifted version of the step response. We don't usually do that. So therefore, the impulse response of a system can be determined from step response by first order differentiating or taking the derivative of this order. Okay. Block diagrams, I believe something we have done before. So often it's convenient to represent a discrete time LTI system in a block diagram form. So such systems are completely characterized by their impulse response. We often label systems with impulse response. So that's why we have always H of N. It is labeled like the system response or the block of the system is represented by the impulse response. Okay. When you have them in series, you just do convolution. It's not multiplication nor addition. That's convolution here. So you convolve these two blocks. And this one here is just parallel formulation, and you just add them together. This series will be needed in the future when we need to do convolution. But in our case, I think when we use the finite sequences, we'll be rarely dealing with this series formation, but we'll use them. And next week, inshallah, we'll do a review for the midterm material. The midterm is after 2 weeks. So next week will be dedicated to make a revision. And remember, we have the energy and power. We talked about them. And these things will be used them to determine the energy and power of a signal or a sequence, and to check if the signal is power signal or energy signal. All right. Consider an input x of n and a unit impulse response h of n given by these expressions. And the value of alpha between 0 and 1. And you were asked, find the output of x of n convolved with h of n. This one here. I will assume yes. Yeah. Check with engineer Haitham, but I will assume there is a lab today. Yeah. Okay. So you have this convolution. Okay. So if there's an arrangement with engineer Haitham, that's fine. Okay. So you have these two sequences, x of n and h of n. And you were asked to find the convolution here. So far we've been doing convolution with finite sequences, like we did the tabular form, we did the matrix form, the standard form, and so on. Now, what about if you are given an expression like this? X of n equals alpha n u of n, and h of n equals u of n. So let's take it to the whiteboard and see how to approach such problems. So x of n. No, not yet. Next week, inshallah, I'll give you the marks. It's going to be alpha to the power n, u of n, and h of n, u of n. Just double check. All right. And the question, find y of n equals x of n convolved with h of n. As going to be equal summation from k equal negative infinity to infinity, x of k, u of n minus k, right? All right, so let's substitute. So from this one, x of k equals alpha to the power k, u of k, and this one here, h of k, u of k. So I just change the variables, change the domain. Instead of n, I'm dealing with k now. So let's substitute x of k, summation, k equal negative infinity to infinity, alpha to the power k, u of k, x of k, h, sorry, this one is h, times h of n minus k, which is going to be u of n minus k. تمام? All right. Now, what do you know about the unit step function? Unit step function is basically starts at 0, start give you pulses of value 1. At -1, how much is the value? 0. At -2, how much is the value? 0. And so on, -3, and so on. Now, when you look at this summation, it's from -infinity to infinity. But I know that this u of k will restrict that my summation starts at 0 because all these values are 0. So this summation will be summation from k equals 0 to infinity, alpha to the power k u of n minus k. Clear? This one here. Alpha to the power k u of n minus k. This u of k just change this term from -infinity to 0 because all negative values of k will have 0 values because of this unit step function. Now, what about this other unit step function? What will be the typical values there? Okay, let's draw this. Let's draw it. I have u of k. So u of k is like this. Hi, u of k. Now, what about u of n minus k? So this is 0, 1, 2, 3, 4. U of minus k is how much? It's going to be the same thing, but reversed. It's time reversal. So that's 0. That's -1, -2, -3, -4, and so on. That's u of minus k. Now, what about, so that's u of -k. Now, u of n minus k will be what? That's at n minus 1, at n minus 2, at n minus 3, and so on. So this sequence will have values all the way to n. Now, this one will lead the summation to be summation k equals 0 to n alpha k. And that's going to be y of n. And now refer to the tables there. I have this exact term there. So the answer will be 1 minus alpha n plus 1 over 1 minus alpha. So that will be the answer for this question. Okay, so let's go back here. And with, again, the restriction that alpha should be less than 1, which we already have it there. All right. So that's how to solve this expression. And there's the output there. And that's it for today. Continuous time, we'll talk about it next week, inshallah. It's going to be the first period. And it's going to be along with the revision. So, and up to next week, that will be the material for the midterm. Like this is the first part of convolution. We did it in discrete. Next week, we'll do it in continuous. Pretty simple. We will not do any complicated expressions. Mostly we'll deal with a convolution between two rectangles. And the output will be either a triangle or a trapezoid. All right. So that's it for today. Let me just close the recording.